This is video assignment number 2. For the first task, I'm going to draw a chiral compound and its enantiomer. Just draw an example on here. So this is a tetrahedradone with 4 different groups attached. So we can just put this random stuff. They're all different though. And then let's see. And it's an enantiomer, so it's an enantiomer. It's going to be a mirror image. So that's going to have just the mirror image. So enantiomers are compounds that cannot be superimposed on its mirror image. Cannot be super on mirror image. So this compound cannot be superimposed on its mirror image. Task 2, draw a pair of compounds that are diastereomers. Get an example here. So just draw. So diastereomers have the same connectivity and formula. But they're different in 3D space. Like this carbon is in the back and this carbon is in front. So this difference in 3D space can also cause it to have different properties. So task 3, so draw a meso compound. So draw example meso compound. Let's just say this. We got like bromine or something up there. Meso compound has, so it's gonna have greater than 2 chiral centers. But it has a plane of symmetry. So meso is always gonna mean it's achiral, because being meso is a property of being achiral. Achiral does not always mean meso. For example, you can be achiral and without having internal symmetry, or if you have only one center. Let's see, so achiral without internal symmetry. So the fact that it is has a mirror image means within the own molecule means that it will be able to be superimposed on its own mirror image, which would mean that it's not achiral, but then it is meso. And then for 4, showed how to determine the RS configuration for the compound. So this compound is pretty complex, but it only has the 1 chiral center. So I'm just going to simplify the compound a little bit. So we have this carbon here. Just draw the chiral center. We have the O in the back, and we have the H down on the bottom. And then we have to assign the importance to them. So the hydrogen is going to be 4. This carbon only has one other carbon attached, so that's less important. And then this carbon has its next over, it has attached to an oxygen, so that makes it pretty important. This is an oxygen connected to it, so that makes it the most. And then to determine its RS configuration, we can change out. We want to put the hydrogen in the back in order to determine the right, or if it's clockwise, counterclockwise, or RS configuration. So to put the hydrogen in the back, we'd have to swap around a few things. I'll draw this one in blue. So to put the hydrogen in the back, that means that this carbon is going to come down to here, because we're basically rotating around this carbon here. But the whole molecule is going to rotate, but I'm just rotating around that so that we can figure out where everything goes. That carbon moves down to here. So C3 goes there. C2 seems in the same spot. And O ends up there. This leads to a, this means this is 1, this is 2, this is 3, this is 4, and we follow the direction of 1, 2, and 3, and we get counterclockwise, and then we get S config. See if I have everything. I think I got everything.